Right, well, good morning, welcome. It's great to see so many people here. Come to listen to me talk. There's no pressure because, of course, you don't get to vote on me. Apparently, I'm going to be good. Really hope I am. Anyway, what I want to do with this presentation is to kind of talk a little bit about open source and OpenJDK. And when I was asked to do the keynote presentation, it was sort of positioned as do something a bit more inspirational, not so quite deep technical. And I thought, okay, so let's have a think about open source. Let's think about how open source has really changed the way that software has been developed and the impact that that has had in terms of the type of software that we have available to us now. And so I started putting the slides together, and I found this picture, which is kind of, it's a nice sort of conglomeration of different things. And I'll leave it up for a few seconds because it's interesting to try and see how many open source references you can spot in here. Because obviously you've got Tux the Penguin, you've got Duke, you've got the Mozilla, what is it, Dragon, I suppose. There's the FreeBSD daemon there, GNU at the top. I'm not quite sure what the fish is, maybe it's glassfish. And then there's a few others in there. But I just thought that was kind of a nice little picture to put up there to see all the different sort of logos that people use. Let's start then by looking at the origins of open source. Where did this really come from? And ultimately, you can kind of go back quite a long way, certainly in terms of computing history, way back to 1983. Because in 1983, Richard Stallman, who's the guy in the middle there, decided to create the Free Software Foundation. What he wanted to do was to create a free version of Unix. And really the reason for this was because back in 1983, and actually more 1984 really, AT&T was this big telephone company in the US. And one of the things that they had was a place called Bell Labs. Bell Labs was a place that created all sorts of new technology and did lots of research. One of the things that came out of Bell Labs was Unix. Originally, even further back, 1969. But there was a legal thing in terms of AT&T, which meant that because they couldn't actually compete in the computing business, they had to make Unix freely available. They could license it to people, but it had to be free. So that was all very good, except that in 1984, there's a voice. Strange. So in 1984, things changed for AT&T, which meant that they could then actually license Unix as a product. So Richard Stallman decided he wanted a free version of Unix, and he created the Free Software Foundation and started the GNU project. GNU being GNU is not Unix, a kind of recursive reference. He started doing this and, got a lot of people involved, started writing a lot of code, and was generally very successful at a certain level. He created a lot of code for libraries. He created a lot of code for compilers. He created a lot of code for command line things. But in terms of the kernel, he was a bit lacking. There was a thing called the GNU herd, which was a kernel that was created by the GNU project. It was based on the Mac microkernel, if anybody's old enough to remember that. But it didn't really sort of succeed in terms of being a project and actually being usable. So time went on. And then in 1991, we had somebody else come along. And the person on the right there you may recognize is not Harry Potter, it's Linus Torvald. And he decided that he wanted a free version of Unix because he wanted to learn about Unix, but he also wanted to learn about 386 assembler. Again, if anyone here is old enough to remember the 386 chip architecture. And so he decided to create this project, which was going to be called Linux. And that was going to create a Linux kernel. And I'll read you this little quote that I found when he was talking about this originally. He said, "I'm doing a free operating system, just a hobby, won't be big and professional like GNU for 386 AT clones. So I think he underestimated quite how successful he was going to be. But what he wanted to do was to find a version of the kernel that was freely available. So as I say, the GNU herd project hadn't really been very successful in terms of creating a kernel. There was another project called Minix, which was started by Andrew Tannenbaum, and that was a teaching version of Unix, which is a kind of like small cut-down version. But that again was restricted to educational applications. So Linus came along and decided he wanted to create a kernel, and so he set about doing that. And so what we now see is the Linux operating system is really a combination of the Linux kernel and the GNU compilers, libraries, and command line utilities. So it's really a kind of combination of two things. It's not quite fair to say that Linux is just the stuff that Linus created. Then in 1997, we move forward a bit in time, Eric Raymond, or Eric S. Raymond, as he likes to be referred to, wrote a paper which was called The Cathedral and the Bazaar. Who's heard of The Cathedral and the Bazaar? Okay, only a few people. Well, this is an interesting sort of discussion about how software is developed. And what he did was he compared the cathedral way of doing things, where you have a small number of architects who decide on the design of something and then have it constructed. So you need a small number of people in charge of the project, and then lots of people coming in and actually creating whatever it is that you're doing. So in the case of a cathedral, you draw some plans, and then you get your builders to come in and actually meet those plans. Okay, let's see if I can turn the sound off. And then he compared that with the open source approach, which is where you have a lot of people getting together and developing software, but doing it in an open way, where there's no really kind of firm, you have leaders, but not a sort of single leader or a single group of leaders. It's very much distributed. People can contribute ideas to how the software should be developed. It's much more like a sort of Bazaar type of area where you've got lots of storekeepers, lots of people trying to contribute things. And really looking at the way that that changes how software is developed. Because it means that with many more people contributing ideas, you have a different sort of set of results. Because there's more kind of people adding things rather than just a few people dictating their direction. So 1998. Anybody remember Netscape? Okay, most people here, good, okay. So 1998 was an interesting year for open source because actually 1998 was when the term open source was first used. Because in 1998, as most of you I'm sure will remember, this was when Netscape were having a bit of a tough time of it. They had created the most popular web browser in the world, Netscape Navigator, and they had been very successful with that back in 1995. Unfortunately, another company came along and started creating its own web browser and shipping it with its operating system. That was Microsoft. And that meant that trying to sell something that somebody else was giving away for free became rather hard. And ultimately in 1998, what happened was that Netscape decided to release all of the source code to Netscape Navigator. And that's what, okay, that's not what I wanted to do. Oh, there we go. That became Mozilla. And subsequently from that, we have Firefox, we have Thunderbird, we have Sunbird, all of these types of projects. But this is when the term open source was first used. So before that, it was free software. Now it's open source. The ability for people to download the source, the ability for people to look at the source, the ability for people to modify the source. That's what open source is. And then in 1998, we had the Open Source Initiative. And the idea here was that a group of people got together and decided to form a consortium of people who were interested in open source. And I've got to say that it's a little unclear to me, actually, exactly what the open source initiative really do. If you look at their webpage, they say that they are dedicated to the idea of promoting open source. And I guess you have people who do presentations about that from there. One of the things that they say that they do is that they are the custodian of the open source definition. Okay, that's kind of an interesting thing, but so be it. And then in 1999, along comes the Apache Foundation, the Apache Software Foundation. This started life because the most popular web server at the time was the Apache web server. Now, interesting question. Does anybody know how they came up with the name Apache web server? Okay, the answer is that it was a patchy web server. They had to keep applying patches to it, so they called it Apache web server, and then that got shortened into Apache web server. Now, clearly, the Apache Software Foundation has been very successful in terms of promoting open source software and the development of open source software. And if we kind of look at the list of some of the projects, this is not all of them, but there's many projects that have been started by Apache. There's things like Hadoop, Tomcat is a very good one, Cassandra, Spark, Felix, and all of these things, Maven, have been developed through the Apache Software Foundation. So a lot of the things that we use as developers, a lot of the things that can be used in terms of deploying applications have come through Apache. And that's why it's been very successful in terms of generating software. It's also interesting to look at the difference in terms of perception versus reality when it comes to open source software. Many people think that the situation when it comes to open source software is on the left, where you've got this large number of people all involved in this project and all doing lots of things and making sure that bugs are fixed and new features are added. Now, that's true with some projects. Yes, there are definitely projects out there that have lots of people working on them. But a lot of them are actually, only one or two people who are doing all the work. And this, in itself is a great thing about open source software because it enables people to develop things, on their own. If they've got a particular thing that they want to fix, particular thing they want to create, they can go off and they can do it, and they can make it something that other people might want to use. And they can do that on their own. They don't have to be part of a big group. They might be, but they don't have to be. So now let's kind of go back a little bit in time, having talked about open source software and the origins of open source. Let's now talk about Java and the OpenJDK. So I'm sure most of you will know that yes, last year was the 20th anniversary of the launch of Java. So way back in 1995, Java was released to the world. And it was a nice platform that lots of people started using. They started creating code with it. They started developing applications. And it became very popular. And then things kind of happened. So in 1997, I found out there's a lovely picture here of, on the left is Scott McNealy, who was the then CEO of Sun Microsystems. And on the right, we've got Steve Ballmer, who went on to become the CEO of Microsoft. So in 1997, there was a bit of a problem, because what happened was that Microsoft had licensed Java from Sun. They wanted to include Java as part of their product in the same way that they had included a web browser and they had included a TCP/IP stack and all those sorts of things. Unfortunately, what Microsoft did was they took the code and they ported it to the Windows platform, but then they kind of modified it a little bit. And they modified it in such a way that it wasn't in compliance with the license. They added a few methods here, they added a few classes there, they took a few classes away, and changed a few things in terms of the standard classes. Now, there's nothing wrong with adding new classes if you don't do it in the standard packages. But if you start adding things in the java.util package or javax.whatever package, that's a real problem from compatibility. So Sun were not very happy about this. And what they did was to basically decide to sue Microsoft. And this led to a lot of back and forth legal wrangling over what was happening in terms of Java. So this was really kind of the start of people looking at Java and thinking, right, we need to have an open version of Java, one that's not controlled by Sun, one that people can use and have as a free and open version. And so in 1998, along came the GNU Classpath project, which was sort of loosely related to the GNU project. And this was the idea of writing a set of classes which replicated the class libraries provided by Java from Sun, and doing it in such a way that it would be open source and freely available. People could look at the code, they could modify the code, and so on. And this is one of those interesting things, again, in terms of naming, because what they wanted to do was they really wanted to call it GNU Java, but they couldn't call it GNU Java because Sun owned the trademark Java, and they were scared that if they called it GNU Java, Sun would come after them and say, "Ooh, you can't do that, we'll have our lawyers on you." So they went, the fundamental theorem of software engineering is that we can solve any problem by introducing a new level of indirection. So what we'll do is we'll call it Classpath, because the class path typically contains something like user lib Java. So we'll have an indirection to the name. So we'll call it Classpath, because Classpath actually includes Java, so we'll have an indirect reference to the name rather than a direct reference to the name. But this was the start of, if you like, the free Java software. In 1999, Sun decided that it was time to make the definition of Java, the specification of Java, more open. Up until then, they had been under some pressure from various other companies, various people, about making Java part of an open specification. If you look at things like C, C is defined through ANSI. And if you look at things like C#, that's defined through the European Computer Manufacturers Association. So there was some pressure from various companies for Sun to do that and to say, hand it over to ANSI, hand it over to ISO, hand it over to ECMA, and make it an open standard. But Sun didn't want to do that. You know, they'd spent a lot of time, a lot of money developing Java. But they realized that they needed a more open way of defining the specification. And they came up with the Java community process. And the idea behind this is that if you look at the way standards are defined, you've got two ends of the spectrum. On one end of the spectrum, you've got where one single company defines exactly what is contained in that product, in that platform. That means that you can create that specification very quickly because there's nobody to argue with. You decide it, you put it in the specification, you create it, and then you give it to developers. But there's not much flexibility because you're not taking any input from people outside of your company. The other end of the spectrum is things like ANSI, things like XOpen, ISO, and so on, all these open standards bodies. And the great thing about that is that lots of people can get together and they can define the standard. The problem with that is lots of people can get together and define the standard because it's kind of management by committee. I've had the great fortune, I suppose I should say, of sitting in some ex-open standards meetings a long time ago. And it really is a kind of a little bit hard work because there's lots of people all trying to put their view forward, all trying to get their view as the way that the standard gets defined. And so getting an agreement can take an awful long time. So Sun wanted to come up with something that was between those two ends of the spectrum. And that's what the JCP is. It's a way of defining the specification in an open way where other people can be involved, but doing it in a timely manner. So the JCP has an executive committee. Zulu, the company I work for, is on that. And they decide which JSRs, Java specification requests, are submitted and then created. Those JSRs all have an expert group associated with them. People who are interested in that technology, people who have a stake in it, and therefore want to help develop that standard. There's a timeline for when the standard should be created and then published. There's public review. People can send feedback. So it's a way of doing the creation of these standards in an open way, but without having all of the sort of baggage of doing it in a much more open way. So that was actually 17 years ago, not 15 years ago now, where we have this way of defining what Java is. And if you look at the JCP, there's this golden triangle of things that you have in terms of the JCP. At the top, you've got the specification. These are the JSRs, the things that actually define what Java is. Java SE has a specification. Java EE has many specifications. Java ME has specifications. You then need a reference implementation, something that you can take the specification, you can create a version of it, and you can then use that. The other thing you need, the third part of the triangle, is the technology compatibility kit. And this is something we're going to come back to in a moment, because this is quite important in terms of the whole story of openness and open software. So we use these three things in order to make sure that everything that's created as a JSR really does work. Because the idea of having a reference implementation is it's a way of proving that what has been defined in the specification can actually be built. There's no point in having a specification if you can't actually build what you've defined. So the reference implementation proves that it's possible to build it. The technology compatibility kit proves that the specification is unambiguous, because you have to write a set of tests that guarantee that whatever implementation meets the requirements of the specification. If there's areas where it might be ambiguous how the specification works, you'll pick that up in terms of developing the TCK. And then you can use the TCK to check that the reference implementation actually meets the specification. So you've got this nice triangle of three different things: the specification, reference implementation, and the TCK. So at this point, we're all good. Everything is moving very nicely. And then in 2005, along came Apache, who is a wonderful organization who likes to create open source projects and likes to create open source implementations. And they decided that they wanted to create an open source implementation of Java, which is where the Apache Harmony project came from. This was a bit of a problem, because they wanted to create an implementation of Java. Great. But according to the golden triangle of the JCP, they would need the TCK in order to verify that their implementation met the definition of the Java specification. So they wanted to license the TCK from Sun. Unfortunately, Sun would not license the TCK to Apache in this particular case. Now, there was a reason for that, obviously, and the reason was that Apache Harmony wanted to make their version of Java completely freely distributable. Anybody could use it for any type of application. And that didn't work for Sun, because Sun had a thing called a field of use restriction on Java. If you downloaded Java from Sun, you could use it for anything you wanted, within reason, on the desktop. You could use it for anything within reason on a server. I say within reason. There were a couple of limitations that the license said, that you couldn't use it for a nuclear power station, for example, things like that. Mission critical or life-threatening applications were ones that were excluded. But otherwise, you could use Java for any type of application on the desktop in a server. The field of use restriction said that if you wanted to use Java in an embedded device, then you had to go to Sun and you had to actually license it specifically for that particular application. And the reason for that was because at this time, 2005, the only way that Sun was actually making any money from Java was through licensing Java to, at that time, handset manufacturers. People like Nokia, people like Siemens, people like Ericsson. They also made a little bit of money from Java Card in terms of the SIM card manufacturers and people like that. But they didn't want to lose that revenue, because if they licensed the TCK to Apache, and then Apache created a free version that could be used anywhere, chances were people like Nokia would go, oh, there's Apache Harmony, we'll use that, rather than using the Sun version, and then Sun were going to lose money. So that was a real bone of contention. Then in 2006, there was a change of leadership at Sun, and Jonathan Schwartz took over. The reason for this was really that Sun was struggling. After the dot-com boom of the early 2000s, it had kind of gone into decline in terms of revenue, and they were looking for new ideas of how to bring Sun back, how to make Sun a successful company again. And so the decision was made to have Jonathan take over as CEO. And he had some new ideas. One of the biggest ideas he had was to open source everything. Open source all of the software that Sun had, with the idea that if it was open source, people could use it, and then they would give us revenue by taking services from us, support services, the kind of Red Hat model. And so this kind of took off, and we tried it. I say we because I used to work for Sun at this time. And it even became a little bit of a joke, because I don't know if any of you actually seen this as a YouTube video. I put a kind of link at the bottom there. And the joke was about we're open sourcing the ponytail. And that was Jonathan's, in this sketch, this was Jonathan's approach to making revenue for Sun, was we were going to open source the ponytail, and that was going to get us revenue. So what happened next? Well, in 2006, so shortly after Jonathan took control, Sun announced that they were going to open source the Sun implementation of the JDK. And that's actually quite a precise way of describing it. Java was not open sourced, because remember, Java is many things. Java is a platform, Java is a language, Java is a set of class libraries. So what was open sourced was the Sun implementation of the JDK. And that became the OpenJDK project. Now, initially in 2006, it was just the Java compiler and the hotspot virtual machine components that were open sourced. Reason for this is that there was a lot of due diligence that needed to be done. All of the software had to be gone through. Sun had to make sure that all of the copyright statements at the top of all the files were correct, had to make sure it actually owned the copyright to all of the things it was actually releasing. So it was not quite as simple as just saying, well, here's a whole load of source code, off you go, make use of it. It wasn't until 2007 that OpenJDK, basically almost all of the remaining code was actually released. There were a few bits that were still shipped as binary bits, because there were things like sound, things like font rendering, some of the color management. Those things weren't owned by Sun as software, so they didn't have the rights to release them as open source code. So at that point, almost everything was open sourced. But that had a little bit of a drawback, because it meant that if people wanted to ship a version of OpenJDK with true open source software, they were still a bit limited. And to address that, a company called Red Hat stepped up to the plate, and they created the ICE-T project. The ICE-T project was about really sort of filling in the gaps in such a way that you could have a completely free and open source version of Java based on the OpenJDK code that could then be shipped directly with something like Linux. So it complied with all the GPL licensing and was available in such a way that it could be shipped with Linux. Subsequent to that, Red Hat then contributed the code that they created back to the OpenJDK project. So now that's been taken into the project, and so the pieces that were binary and weren't open source before now are. So at this stage, OpenJDK is completely all open source. In 2007, things kind of went a bit downhill. So the idea of open sourcing everything, I suppose it's a little bit unfair to say that that was the only thing that affected Sun at that point, because there were other things that contributed to the decline of Sun at that point. But if you look at the Sun share price, we hit this very nice point in sort of 2000 when the dot-com boom was in its full flow, and we couldn't sell, or we couldn't manufacture enough servers to ship to our customers. And then suddenly everybody woke up to the fact that all these dot-com companies weren't actually going to be able to make any money, and so there was a bit of a decline. Things kind of picked up a bit for a while, but then in 2007, things started to slide again. And you'll see there's a little bit of a sort of pickup at the end there. The reason for that was that a decision was made. And so this is more recent history, where Oracle agreed to acquire Sun Microsystems, and then Sun became part of Oracle. So this then led to a change in leadership of the custodian of Java. This meant that things were going to change. And Oracle came along, and they made some decisions. They made some decisions which were actually, in my opinion, very sensible, but didn't necessarily make everybody happy. In terms of the OpenJDK, what they said was, right, we are very dedicated to the idea of having the OpenJDK. We think this should be the reference implementation for the Java platform. And they actually sorted out some of the issues that had been causing problems for Java for quite some time. They talked to IBM. They got IBM to become part of the OpenJDK project. Now, IBM had been one of the biggest contributors to the Apache Harmony project up until that point. So having IBM move from Apache Harmony to being part of the OpenJDK was a really big step. And it meant that the Apache Harmony project really didn't have a future at that point. The other thing that they did was they got Apple involved. And this was quite a nice thing because there was a big sort of outcry because Apple decided to stop supporting Java on the Mac platform. A lot of people got upset by that, but then a week later, Apple said, we're joining the OpenJDK, we're going to contribute all of the source code that we have for the Mac port and make it possible for Oracle to deliver a Mac port, a binary distribution for the Mac, which we don't then have to support. So that was a nice way of doing that. And people like SAP as well, who have a big interest in JVMs, big interest in the Java platform, got involved as well at this point. So there's a number of big companies who've either contributed code or are actively involved in the OpenJDK and making sure it's a success. In 2011, Oracle delivered Java SE 7. Now, this was something that had taken a long time because if you go back to Java SE 6, that came out in December of 2006. So it was 5 years between major releases of Java. And the primary reason why it took so long, actually there was probably about 3 reasons why it took so long. One was the fact that Sun got a bit distracted and decided to go off and do this JavaFX project, which they thought would be a big thing that people would be interested in. Another thing was that obviously Sun was a bit distracted in terms of revenue and may not have had as much engineering resource to dedicate to creating the next version of Java. But really the primary thing that held up Java SE 7 was the TCK disagreement with Apache. And so Oracle said, right, that's it. We're telling Apache that we're definitely not going to license the TCK to them. Apache Harmony is never going to get the license. And so Apache said, right, okay, we're fine with that. IBM have left. They've gone to the OpenJDK project. We will stop the Apache Harmony project as an active project, and we will leave the JCP. So although it didn't make everybody happy, it did solve the problem. So now Oracle were able to release Java SE 7. They could get the JSRs through the JCP process, because Apache was holding things up because of this disagreement over the license of the TCK, and we had Java SE 7. And for the last sort of 5 years, Oracle have been very good about creating new versions of Java. We've had Java SE 7, we had Java SE 8 with some big new features in it, and we're going to have Java SE 9 next year. And so I just put a few sort of big points on this slide to show some of the things that have gone into versions of Java since Oracle took over the stewardship of it. Lambda expressions, streams, Project Coin, the removal of the perm generation, fork join framework, invoke dynamic, adding a bytecode that enables dynamically typed languages to run in a better performant way on top of the JVM. So this is all good. So let's go back to the OpenJDK project, talk a little bit more about that and how that's actually delivering on what we need as open source software. And the first thing to do is to look at what OpenJDK consists of. There's a number of different components. The biggest part is the JDK part, so that's like the compilers, the tools, and things like that. There's Hotspot, the virtual machine itself. There's some different bits, things like Nashorn, which is the JavaScript interpreter. There's some libraries around JAX-P, JAX-WS for web services, those types of things. So there's a lot of different components that make up the OpenJDK. The other thing that's very interesting in terms of the OpenJDK is how it's used. And so here's an example. 2014, it's a company you may have heard of, Twitter. And they originally wrote their platform in Ruby. That meant that they could create it very quickly, they could prototype it, they could get it running, great. What they discovered was it wasn't going to scale to the kind of levels that they needed as Twitter became more and more successful. So there's actually a talk on this, Twitter Scale Computing with OpenJDK. They decided they needed to run on top of the JVM. A lot of their code is written in Scala, there's a fair amount written in Java, but it's JVM code. So they execute it on the JVM. And they looked around and they thought, well, yeah, we could take the JVM from Oracle, but we think it would be better if we used OpenJDK. And then what they've done is they've actually hired a number of engineers to work on the JVM internally within Twitter. So they've got some great, actually ex-Sun people working on things like garbage collection so that they can tune the JVM specifically for their type of application. And that's a really good example of how open source software succeeds. Because, yes, they could have taken the normal distribution that came from Oracle, but they decided that for their specific application, it was actually worthwhile taking the open source software, getting engineers in their organization to work on it, modify it, make it perform the way they wanted to. And the nice thing is that then they're actually feeding changes back from some of the work they do into the OpenJDK project. So it's not a one-way flow. It's also allowing changes to come back into the OpenJDK project. If we look at activity, I found there's a thing called openhub.net, which allows you to track various activity to do with open source projects. And this shows from 2008 through 2016 the number of contributors who are actually adding code to OpenJDK. And you can see there's a nice upward trend. I mean, it sort of varies from time to time, but it's a nice upward trend. And so there's a bit over 100 contributors to the OpenJDK project. Now, clearly, OpenJDK is a big project, so getting involved is quite a commitment. It requires quite a lot of sort of work on your part in order to make sure that you're not changing something that you shouldn't change. People don't want to have any changes integrated in the OpenJDK that might break things. So kind of looking at the statistics, this is just a few days ago. OpenJDK, just over 33,000 commits made by a total of 389 contributors, representing a whopping 6.5 million lines of code. And to put that into context, if you look at Android, which is another open source project, which uses a lot of open source code, that had a lot more commits, 524,000 commits, had about 10 times as many people committing it to it, but only about twice as many lines of code. So from the point of view of activity on the OpenJDK, there's a smaller number of people working on it, but there's quite a significant amount of code being added to the OpenJDK project. Now, if you're interested in getting involved in this, how do you get started? Well, there's a nice book that's actually been written, which is the OpenJDK Cookbook. And that takes you through the steps you need to do in order to download the code you need, set up the build environment, actually build the OpenJDK. And then there's even some examples it goes through in terms of how to make modifications, how to, put changes, well, in theory, put changes back if you become a contributor and so on. So there's a nice set of information there that helps you understand how to get involved in the OpenJDK project. And also on that sort of theme, there's a big drive around what's called Adopt OpenJDK. And this was an initiative that was started by a number of the Java user groups. Just out of interest, who's a member of a Java user group here? Okay, only a few people. Okay, interesting. But it was an initiative that was started by a number of Java user groups who wanted to help develop Java and help get code into the OpenJDK. So there's all sorts of incubator projects there. There's a lot of open source code that you can work on. There's from the very, very simple to the very, very complex. So they start off with things like, fixing spelling mistakes in comments. That's the kind of level that you can start at. And then moving on to rewriting the garbage collector. Well, maybe not. But it's this idea that you can start simple and work up to more complex things. The idea is obviously to improve the OpenJDK and therefore Java itself, and really to make contributions to how the source code is developed. In terms of getting started, there's a number of different places you can go. So there's, well, you'll get the slides, so I don't need to read all of this out, but there's on java.net, there's a project for Adopt OpenJDK. There's a GitHub repository, there's a Bitbucket repository, and there's also a wiki page. So there's lots of information. If you don't want to buy the book, then you can use this information. You can find out how to get started on that. I'm going to talk a little bit about Zulu.org. Now, OpenJDK is open source. And anyone can take that source, anyone can build a version of it, and they can ship it as a binary, so long as it conforms to the TCK. Azul, the company I work for, is a licensee of the Java source code. It's also a licensee of the TCK, because we have a commercial JVM that we need to verify passes the TCK. So what we do is we take the OpenJDK source, we build it as pure OpenJDK source, and then we make a free distribution available to you. So if you don't want to necessarily use the Oracle version, then you have an alternative. And this is, again, one of the nice things about open source software, is that you can have alternatives in terms of the implementation that you use. So if you're interested in this, have a look at Zulu.org. We have distributions of Java SE 6, 7, 8, and 9. So we've got past, present, and future. So just to kind of wrap up, I would encourage people to get involved. Open source software succeeds when you have more people involved. The more people who get involved, the more code that gets contributed, the more ideas that get contributed to the project. So if you think that there's something in Java that could be done better, get involved. Contribute these ideas, let people know, share that idea, maybe write some code, contribute that, get people to look at it, say what they think. And that really is all I have to say. I think in terms of the question that I posed at the beginning, open source and OpenJDK, do they deliver? I think the answer is yes, they do. Because you have the ability to look at the code, you have the ability to modify the code, you have the ability to download multiple implementations. So with that, thank you very much. I guess I have a few minutes for questions if anybody has any. Or not. I don't see anybody. Oh.
Is this on?
Yes.
Could you elaborate a little more? Like, what is the prime motivation for experienced senior developer to actually contribute to this? Because, well, there is no revenue, there is a lot of time spent in it. So somehow the developer that does this need to have a feeling that it, I don't know, makes the world a better place. Is that the motivation, really?
Yeah, I mean, obviously that is a good question. It's like, why would somebody contribute their time and effort for free to a project like this? And I think there's a couple of ways of answering that. One is the purely altruistic approach, which is you think to yourself, I'm a developer, I would like to make life easier for other developers around the world, and so I will give some of my time and effort to make the platform better so people can do things without quite so much effort. But there's another sort of view that I give, and quite often I go and talk to students. And it doesn't only apply to students, but when I talk to students, I say, if there's one thing I can suggest to you, it's get involved in an open source project, because this is an excellent way of showing potential employers what you can do. If you contribute code to a project, if you've been involved in that project, you've done something with that project, you can show a potential employer that that's what you can do. And they can look at that and go, ah, right, that's a great reference for what that person is capable of. And that also applies to a professional developer. You know, if you're looking to move your career forward, why not get involved in an open source project? If you've got a specific area that you want to move into, use the open source project as a stepping stone to moving your career in that direction, because you can get involved in the project for no cost. You know, you figure out what you want to do, you learn about it, you contribute. And then you can go to somebody, a potential employer, and say, well, okay, I've been doing, I don't know, Java EE for most of my career, but I really want to get into machine learning. Look at what I've done with this open source project. I've added these features, you know, and then they can know, oh, okay, yeah, you know, he understands what he's talking about. He's got the experience, if you like, to back that up. So I think that's kind of one of the things I would use as an explanation for why people should get involved in open source projects. Nope, can't see anybody else. Let me guess, right at the back. Way at the back.
Thank you. Thank you for noticing me. I'm a humble person. Just question is, okay, how you manage actually all this thing to work? I mean, the technical ways, how you track tickets, who assigns those tickets, who actually tests things, who builds, I mean, do you have any CI? What is what is beneath the hood?
Right. So this is where, obviously, having a Bazaar rather than a Cathedral becomes more of an issue. Because if you're thinking to yourself, okay, well, if you've got a Cathedral builder, somebody comes along, creates the plans, somebody oversees that to say, right, you do this, you do that, we put it all together, up comes the Cathedral. Whereas with the Bazaar approach, you've got lots of different people all sort of throwing things in from the sides. So it's a very good point. If you're going to be successful in an open source project where you are going to have lots of people contributing, then you do need at least some level of, well, I use the word management. You do have to have somebody or a group of people who kind of oversee that project. And that, you know, happens in most projects, certainly most projects that have any number of contributors to that. Then there has to be sort of senior level people involved who at least oversee the infrastructure, who decide, you know, whether somebody should be a contributor to the project and have contribution rights. So you do need some sort of level of management. You can't just have a kind of free-for-all and expect it to just kind of magically work somehow. Yeah, so it's a good question, but yeah, you do need to have some sort of management.
And then natural question would be, what is this management in OpenJDK, and actually who assigns this management?
Right. I'm probably not the best person to answer that, but did you want to say something? Okay, so Dalibor's down here. Dalibor's from Oracle, and he is the product manager for OpenJDK. So he is probably the best person to actually address that. But ultimately, in terms of OpenJDK, most of it is managed by Oracle, simply because, you know, they are the people who, from Sundays, you know, started the project. So they are the ones who run the sort of top level management of that. But if you want to talk to Dalibor, he will give you a much more fine-grained answer to that. Okay, I think I'm just about out of time. So again, thank you very much.